Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics for grade 10 level. This is very, very important in our revisions as we have done a lot of topics and we have considered some of the revisions from past exam papers, like working as single questions for a certain topic. But now we want to consider the question paper of June 2022. That is the provincial examination from Gauteng province. Okay, that's mathematics paper 1, guys, by the way. 1 hour, 50 marks. But as we know, guys, I do not spend 1 hour. I can spend more than that or less than that, depending with the explanations that I need you guys to understand. Remember, it's not about the question that you are answering. It's about you answering another question. You don't need to like have repetitions. You need to know one thing, then you can use it to answer as much as you can. All right, so make sure that you read your instructions and information. Mostly the issue of showing your calculations. All this part is about showing off your calculations, and also wherever it's necessary, you're supposed to round off your answer to 2 decimal places unless it is stated otherwise in that question. And also number the questions accordingly. Diagrams are not necessarily drawn to scale, and also you're supposed to put your work into neat part. You're supposed to present your work neatly in whatever that you do. All right, this is question number 1. Question number 1, which is 1 mark actually. All right, it's a direct question that I want you to just understand. They are saying here, given that A is such that, right, is equal to 1 over the square root of x, the square root of 3 plus x, where x is an element of our values from 0, 1, 2, up to 3. These are the values of x in this set. So it's a set that is representing the values of x. So for which value or values of x will the expression A be rational? All right, this expression, for which values of x or for which value of x, it can be a 1 value, there can be 2 values, we do not know. All right, so this one, remember from your rational numbers, this is the first thing that you're supposed to ask yourself, what am I referring to when I'm considering a rational number in that case? So considering a rational number is supposed to be in the form of A over B. Remember the format, we're supposed to present it as a fraction, talking about recurring decimals, talking about terminating decimals. All these parts, they are part of the rational numbers, whereby your A, it should be part of the integers, element of the integers. The same thing with your B, it must be an integer, but this B, since it is in the denominator, it is not supposed to be equal to what? It is not supposed to be equal to 0. All right, so the case is that you are simply checking each value. That is the case of this question. You're simply checking each question. You're given that A is equal to 1 over the square root of 3 plus x, like this. You are simply testing each and every value that you're given. Are you going to obtain A over B? What is A over B? That is our rational number concept, whereby these are integers, right? So that is what you're going to consider in that case. Let us start with a 0 in that case, all right? We are going to start with a 0. If we substitute our x being a 0 here, as we can see, guys, 3 plus 0 is what? It's a 3. So we are going to remain with 1 over the square root of 3. All right, let me just write it aside here. We're going to remain with 1 over the square root of 3. Is the square root of 3 a whole number? It is not a whole number. It is not an integer, because we're talking about positive or negative whole numbers. So the square root of 3 makes this number not to be a rational. The denominator there is supposed to be an integer. So this is totally out. So 0 is totally out. All right. You move on to 1. You do the same thing. You place a 1 in place of x. So you can actually do that on your calculator, guys, and test if you are having exact terms there. We can actually test that. All right. So you can even test on your calculator. You just put in your values. That is 3 plus 1, which is 4. And you're going to have 1 over the square root of 4 in this case, which is giving us 1 over 2. So as we can see, 1 over 2 is a rational number. This is a rational number since we are having the fraction A over B, in that case being whole numbers. So all of these ones, they are whole numbers. So we are having if you express it as a decimal, it's a terminating decimal 0.5. So meaning to say this gives us a rational number at x is equal to 1. So this is part of our answers. All right, we move on to a condition when this x is equal to 2 this time. You substitute 2 here, but as you can see, guys, if we add 3 plus 2, that's a 5. So it is going to be 1 over the square root of a 5, of which the square root of a 5 is not an integer in that case, all right? So we are not going to have this as a rational number. This is not, so meaning to say we are not having a value there at what? At 2. It's not a rational number that you're going to have at the end. You do the same thing if this is a 3. You're going to substitute a 3 in place of x, so that will be 3 plus 3, which is a 6. So 1 over the square root of 6 again is not, because you can't determine the square root of 6. The square root of 6 is giving us a value that is an endless value, which is a non-terminating value. That's less the square root of 6 like this. Just check this value, guys. 2,4 it's an endless value that you have. So that means this is not a rational number because it must be a terminating, not a non-terminating. So the only value that we had that gives us our x, that gives us this a to be a rational number is when x is equal to 1. So that is a condition where x is equal to 1. All right, so that was how you're supposed to actually have your question. Just try test your values as you are moving. All right, number 1.2, we are now given factorize the following expressions fully. All right, we are supposed to factorize fully. 1.21, we are given in this case 2x squared minus 32. So if I am to consider this, I can see that there's a common term. Remember the golden rule, you're supposed to factor out what is common in the first place, right? You're supposed to factor out what is common. All right, let me just do this. All right, it's like this. So in order for you to do that, you can check between the numbers that you have. You've got a 2, you've got a 32, and we can see that there's a common term, which is 2 is the highest common factor. Here we've got x squared, but here we do not have a variable. So you cannot use x to be a common term, but 2 can be a common term. The highest common factor between these two is going to be 2. You factor out that 2. So if we factor out 2, remember you have to divide. So that's 2x squared divided to these 2. What are we going to have if we divide 2x squared divided by 2? So this and this will cancel. The numbers are the same. You remain with x to the exponent of 2. So that's x to the exponent of 2 minus 32 divided by 2, which is going to give you a 16 in that case. All right. So the question is that, am I done factorizing? Is it factorized fully? Because it is supposed to be fully factorized. So in order for us to have this fully factorized, we are supposed to check through and see how can we factorize further if there is a possibility for you to do so. So in this case, yes, there's a possibility, because as we check what is inside of the bracket is a difference of 2 squares. X squared is a perfect square, 16 is a perfect square. So whenever you've got a negative, always test if you have got a negative in between two terms, that is for a binomial expression. Always test for a difference of 2 squares. How do you test? Can I obtain the square root of x squared? Yes, we know that the square root of x squared is what? It's x. Can I obtain the square root of 16? Yes, we know that the square root of 16 is plus or minus 4. So the moment you understand that, you know that this is a difference of 2 squares, because it's only a perfect square that gives us a whole number at the end, an integer at the end. That gives us an integer as our answer, meaning to say we have a difference of 2 squares. Yes, you can apply your formula for the difference of 2 squares. Remember that a squared minus b squared is equal to a minus b into a plus b. But this simply represents the square root of a squared, which is this a and this a, the square root of b squared, which is this b and this b. So that is the condition that you simply need. You're just going to need the square root, and we talked about this in the previous part. We said the square root of x squared, which is x, and you also have x, the square root of 16, which is plus or minus 4. So you're going to have one bracket subtracting, so that's a minus 4. Another bracket is going to add the square root of this number, which is you subtract in one bracket, you add another one. So this part you can even start with x minus 4. It's not an effect at all. You can start with the bracket of x minus 4 followed by the bracket of x minus 3. That is how you can answer these typical questions. All right, let us move on to 1.22, which is again on simplification of factorization. So in that case, we are given that's 1.22, that is 6a squared minus b plus a into 2 minus 3b. In most cases, they will give you something of this nature, whereby here there is a common term, where you can factor out a common term so that you obtain the same bracket as this part that we see. But on this question, it was a different situation. It was a different situation because we can see that between the first two terms, we do not have anything common. Between 6a squared and b, we do not have a common term. All right, so that means I'm stuck. I cannot factorize this. So what am I going to do? All right, let me think of the brackets. That is the thing that I have, because I know that I can expand these brackets, collect the like terms, then I can factorize further. So let us expand our brackets in that case. So if we expand the brackets, you multiply by positive a, which is the number that is on the bracket closer to the bracket, that is the term that we have there is a positive a. So it is going to multiply inside of the bracket each and every term inside of your bracket. So that's a times 2, which is a positive. Remember, positive times positive, it gives us a positive. Then it's plus a times minus 3b. So a positive and a negative, it gives us a negative. So that's negative 3ab, like that. So the question is, yes, we have expanded, guys, our expression. We have expanded it, we've expanded our brackets, but can I factorize further by grouping? That is what you have to test. Remember, we said these two, there is no common term. So there is no way I'm going to divide it this way, because if I divide it this way, I'm going back to this scenario that I had before, because I'm going to factor out what is common here as this part, which is our a, but here I'm going to be left with nothing common. So that means in that case, you cannot factorize by just grouping into two like this. You have to rearrange your terms. So you are going to rearrange in your terms so that you'll be able to factorize in terms of what? Common factors. So you have to check now throughout. Here I've got a, here I've got a, so I can maybe take these two. Let me check the last two, what's gonna happen. I've got a b here, I've got a b there. So that's I can do that way. I can do that way. All right. So meaning to say, I'm gonna take these two, I take these two at the end. All right. So let's see. If we take these two, we are going to have it as 6a squared plus 2a in that case. I'm just rearranging. I'm just taking this to the other side. I'm not transposing to the other side of the equation where the number or the term has to change the sign. No, I'm just rearranging our terms so they remain with the sign as they were having before. You do the same thing on the negative b. It is remaining with this side of negative 3ab. But on rearranging these two, consider also that here, if I am to factor out, I'm going to see, all right, I'm going to be left with a here because this one is the smaller, is the one with the smallest exponent. So yes, you have to check also to say, all right, as I'm factoring out here, I'm going to remain with a, but here I'm not going to remain with a because it will divide with a. I'm just going to remain with a number. So on your rearranging, if you consider that b is the common term, so it means once you factor out that b, you're going to remain with a. So it's best for you to start with the term that has got an a, where we are going to remain with a. If we factor out b, we are going to remain with a here on negative 3b. So it's best for you to write that way. I'm not saying it's wrong for you to write minus b minus 3ab, but most of you guys, you tend to have a confusion later on seeing that whatever that you're going to factor out at the end is the same. Most of you tend not to see that, and you end up manipulating a lot of things, changing a lot of things, of which your answers will be actually correct, but you are now making your answers wrong. All right, so I'm not saying it's wrong, guys. All right, so I'm gonna take this and the last part, which is minus b. You understand me at this stage. You understand me very, very much. I hope at this stage you understand how and what was the reason. Now, all right, let us consider factorizing now. Do we have common terms? Definitely we have, because the moment that we made us to rearrange, it was for us to have common terms between the two numbers. So there 2 is common and also a is common. And I said you take the one with the smallest exponent when you find the highest common factor. So the highest common factor of 6 and 2 is 2, of a squared and a is a. You divide that here, you divide also here by what? By 2a, which is your highest common factor. So if we were to divide 6a squared over 2a like this was going to cancel 2 into 6, that was going to be a 3, that like 6 divided by 2, which is a 3. Then a squared and a, if we divide here, going to remain with a, or you just use your exponents 2 minus 1. Since you are dividing same powers, you subtract the exponents. All right, so that means you're going to be left with a 3a. 3 times a, that is 3a. So this will give us 3a. 2a divided to 2a, as you can see, guys, these two are the same. So they will cancel each other. We remain with a 1. Okay, now let us consider that side, because remember what I told you guys on the introduction of factorization. If you never watched those videos, make sure that you watch them so that you understand your factorization. I told you guys that once you consider a condition like this, you are supposed to factor out here whatever that you do so that it will be the same as what you have in this bracket. So meaning to say, I'm going to consider that I have got positive all through the bracket. So in order for me to have a positive here, because there's negative, I'm going to factor out a negative so that it becomes a positive. And as you can see that b is common, so you're going to factor out negative b. All right, now let us divide. We're going to divide negative 3ab divided to negative b. It's going to cancel negative 3ab over negative b like this. The negative and the negative will cancel. B and b will cancel. We remain with the positive 3a. So this is 3a. You move on to the negative b. That will be negative b over negative b like this. This and this cancels. B and b cancels. We remain with a 1. So it's going to be a positive 1 since we have cancelled. So as we can see, guys, this bracket and this bracket are the same. This is where I was saying most of you will tend to have confusion, because if you used the arrangement that was going to happen here, you're going to have 1 plus 3a like that. 1 plus 3a and 3a plus 1 are the same. Remember, we said a plus b is equal to b plus a. So these two are the same. So most of you tend to say these two are different, and meaning to say now you are no longer factorizing that because you are telling yourself they are not the same. So that is what you're going to have if you used in that order of minus b minus 3ab. You were going to have here 1 plus 3a, which is the same as 3a plus 1, like I'm just explaining in this case. So meaning to say here, we are having the same bracket. So what are we going to do? We factor out that common bracket of 3a plus 1. Then you remain here with the 2a. Here you remain with minus b. All right. If you divide, you are going to be left out with minus b on that part. So this is what I was expecting you guys to have at the end. Let us just try to revise as much questions as we can so that you'll be able to simplify whatever question that you'll be given. All right. So let us move on to question number 1.3. 1.3, we are given another algebraic expression, but this time it was to simplify, not to factorize. All right. It's already in a factorized manner. This one, they want you to simplify this question 1.31. How can we simplify this? We have to expand the brackets. So that's 1.31, whereby we are given x minus 1 into the bracket of x squared plus x plus 1, which is the whole of this bracket that we have. So remember, in order for you to simplify, you have to ask yourself, this is something that is already factorized. So meaning to say to simplify is the opposite of what is done. That is, you are supposed to expand the brackets. So the question was supposed to be expand the brackets. That was supposed to be the question. But they just wrote simplify. What am I simplifying? You have to ask yourself, all right, this one, it is factorized. So the opposite of factorizing is to expand. If it is expanded, you have to factorize like this part. We were having expanded terms. We factorize them to put them in brackets. These ones, they are in brackets, so they are factorized. So we have to expand. So let us expand, guys. Remember, guys, I talked about this also on our introduction. I told you that x must multiply every term. X in the second bracket, x must multiply x squared, x must multiply x squared, x must multiply a 1. So every term is multiplied by x. So that's x times x squared, which is x to the exponent of 3. Remember, x and x squared, you're going to add the exponents because the powers are the same that you're multiplying. So you add your exponents, which is going to be x to the exponent of 1 plus 2, which is x to the exponent of 3. All right, so that is it for this part. Then you move on to x and x. So x times x, which is going to give us x squared, right? Then x and 1, which is going to be x. You do the same thing with minus 1. We are done with x. We move on to minus 1. You do the same thing. So it's minus 1 times x squared, which is minus x squared. You do the same thing, minus 1 multiplied to positive x. So it's minus 1 to positive x, which is minus x. Remember, negative, positive. When you multiply a negative to a positive, it gives you a negative number. All right. Then you do the same thing, negative to positive 1. We are back, we get a negative 1 in that case, because you're multiplying a negative to a positive, you're going to get a negative at the end. So that was your expansion. Then you can collect your like terms at this stage. You are supposed to collect the like terms. So by collecting the like terms, you are now simplifying further. So remember, I told you that the like terms must have the same exponent. It's not about being just an x. No. It must have the same exponent also. So considering x to the exponent of 3, we do not have any other x to the exponent of 3. So that means it is just going to be written as it is. But we have x squared here to the exponent of 2. To the exponent of 2, they are the same. So those are like terms. So you are going to subtract. How? This is plus 1. This is minus 1. So that's 1 minus 1, which gives us 0x squared. But 0x squared is same as what? Is same as 0, so there's nothing there. All right, we are done. We're going to get a 0, so there's nothing. You move on to x. There is x here, there is x here, same exponent, right, which is 1 and 1. So you're going to subtract again 1 minus 1. So that's 1 minus 1, which gives us 0. So it was supposed to be 0x, which is same as what? Which is same as 0. So you'll be left at the end with negative 1, which is a constant. You do not have any other constant. So that is going to be a constant. And if you check this part we talked about, it also on our factorization from the difference of 2 cubes. Remember, we've got the difference and sum of 2 cubes. So we talked about this type where you factorize, you get this. So the question might ask you to factorize this. All right. So remember our concept that if we have a to the exponent of 3 minus b to the exponent of 3, we get a minus b into a squared plus ab plus b squared. We just have to know your laws, guys. And if you have a to the exponent of 3 plus b to the exponent of 3, we are going to obtain a plus b in this bracket, a squared minus ab plus b squared to factorize this. So that's it. All right. So there, guys, just make sure that you watch your introduction. All right. I think that can actually help you a lot. Make sure that you watch the videos of the introduction. Those ones will help you to move together. All right. On 1.32, it was a simplification of addition and subtraction. So subtraction and addition. So it's a subtraction and addition of fractions where we are given x plus 7 over x squared minus x minus 6 minus 3 over x minus 3 like this plus 2 over 2x plus 4. So this is the expression that we are given to simplify. How do I simplify such type of expressions? That is the question. How do I simplify? Remember, on addition and subtraction, the first thing, factorize your terms so that you see you can properly see the LCD or the LCM, which is the lowest common denominator, all right, or the lowest common multiple if you consider in terms of a multiple. So in order for you to properly see your multiple, which is the lowest common multiple, you have to factorize your expressions. So the first part, there's in the numerators, whether there is a common term or what, you do not factorize them. You factorize the denominators where it is possible for you to factorize, meaning to say I'm going to be left with x plus 7, everything over the denominator in this case being factorized means I've got 2 brackets in that case, all right? So consider that I've got a 1, all right? Consider that I've got a 1. So the question is, if I have a 1 there, I'm going to have x and x so that I obtain x squared. So this will be x here, this will be x. Then remember what we do, we move on to the constant, which is -6. You have to find 2 numbers that you multiply to obtain a -6. These are factors of -6, 2 numbers, but they must add up to -1, which is this part on x. So you have 2 numbers that you must multiply to get a -6. As you can see, to get a -6, it means one of the numbers must be a negative. Let's say I've got -1 and a +6. If I multiply these 2 numbers, I get a -6, or I can interchange this 6 and -1. If I multiply these 2 numbers, I obtain -6. All right, but if I add, that's the question. So you have to find other factors. We've got -3 and 2. If we multiply these 2 numbers, we get a -6. I can just interchange the sign to put a negative this side because I'm supposed to get a negative value on the multiplication. So all these numbers that we see, all these factors that we see here, guys, if you multiply them, these numbers, they will give you a -6. But remember, it is not just obtaining a -6 by multiplying. We must add them so that they give us this middle term, this number here, which is -1. If we add, so now we are going to add throughout -6 plus 1. So you can even try this on your calculator throughout, so that you see which part gives you -1. So that's -6 plus 1 like this, which is going to give us a -5, which is not -1. All right, you move on, you do the same thing, 6 and -1, you do the same, you add 6 plus -1, which is a -1 like this, you're going to obtain a 5. So this will give us a +5, not minus x. You move on to the same situation and so on and so on. So you're going to see that if you move on to -2, it's going to be -3, -3 plus 2. In that case, it gives us a -1, which is the one that we want here. All right, if you do the same thing here, you're going to obtain a +1, not a negative. So that means, guys, the 2 factors that we have been looking for all along, that you multiply them to give you a -6, but if you add them, they give you a -1. It's -3 and +2. So we are going to have a -3 and a +2. So this gives us the factorized part of x² minus x minus -6. So that is how you can play around with your factorization. If you know these factors, no need for you to write them the way that I'm doing here. If you know them, just doing for the sake of all of us to understand. But if you know these factors direct, guys, there is no need for even you writing them down. All right, so this x minus 3, there's nothing that we can do. It's already in its simplest form. Then we've got here, there was something that we had 2 over 2x plus 4. All right, so if you consider this, this is going to be 2 over. If you consider 2x plus 4 there, there's a common term that we have between these 2 terms, which is between the binomial expression, which is 2. 2 is common there. So I can factor out the 2 in this case. If I factor out 2, it's going to be 2x divided to 2, which is x. Then I do the same thing on 4. 4 divided by 2, which is a 2. But as you can see, there's a miracle that is happening here, because the 2 in the numerator here and the 2 in the numerator in the denominator are the same. The numerator one and the denominator one are the same. So what does this help? Or what is it going to help us? We can cancel them. 2 and 2 can cancel out. We get a 1 on top. So this can be written as 1 over x plus 2. Instead of us having 2 over this, we can just write in simplest form 1 over x plus 2 like that. So the question now is, we are back to the addition. Yes, you can actually find the determine the LCD of everything. You combine this and that. All right, but I told you guys I'm going to come out with different methods in our simplification. I want us to talk about this method. I talked about it on fractions separately, and I want to talk about it again in this video, so that maybe some of us might also learn. Maybe you didn't watch the introduction. All right, I told you guys that you can have this in this manner, where you can just determine your LCD in that case, right? Instead of you having it under this term, you are not going to do that. Remember that. I want you to go back here. Remember what I said. If you are given A over B, all right, let's consider A over C plus B over C, like this. If these are the same, it means I can simply combine what I have in the numerator together. That is going to give us A plus B, everything over C. Provided it's only the denominators that are the same. So having that in mind, it can help us a lot, because we are going to consider to say, all right, if I find the LCD of this, as you can see, I've got x minus 3, I've got x minus 3, it is appearing once, so I'm just going to take it as x minus 3. I've got x plus 2, I've got x plus 2 appearing once on each part. So this becomes your LCD in that case, which is your LCM or the LCD. All right. So what you're going to do with this method, all right, this is what you're going to do with this method, guys. You are going to make sure that each term, please be careful, listen to me properly here. You are going to make each denominator to have every term that we have here, or every bracket that we have here on our LCD, which is x minus 3 and also x plus 2. So if we check on the first part that we have here, we already have all these here. There is x minus 3, there is x plus 2. So on that part, there is no effect. But in actual sense, we're supposed to multiply like this by x minus 3, but we already have it there. We already have the x minus 3 and the x plus 2. So this part does not make sense, because we already have this. Let us move on to the second term. You understand what I'm trying to say. Okay, this is what I'm trying to say. As we can see here, there is x minus 3, which is the one that we also have here. But we do not have x plus 2. But here we have x plus 2 on our LCD. But here we do not have it. So what do you do on that part? You multiply by the part that you do not have. I do not have x plus 2 in the denominator. So I'm going to multiply this case so that I have x plus 2 in the denominator like this. But I do not just multiply in the denominator only. I have to also do it in the numerator. So I'm going to use x plus 2 over x plus 2. If you consider, guys, what is x plus 2 over x plus 2? It is a 1. So we are simply multiplying by a 1, and by multiplying by 1, I told you that it does not affect your question. All right, I'm removing what I want. All right, it does not affect your question if you multiply by what? By 1. So you are going to use x plus 2 over x plus. So what we just want is these denominators here to have everything that we have on your LCD. Once they are like that, it means they are all the same. Okay, let us move on to the other fraction here. Our denominator here, there is x plus 2, which we also have here. But we do not have x minus 3 there. We do not have x minus 3. That we have on our LCD. So we are supposed to multiply by x minus 3 over x minus 3 to add it on this part. So we are simply going to multiply whatever that you have here. You're going to multiply by x minus 3 over x minus 3, so that we have exactly what we have in the denominator. We've got x plus 2. We've got x plus 2. We now have x minus 3, which you also have here. So guys, once you know, guys, I think this is the easiest way. Once you know this, we are now back to this part that was that once the denominators are the same, you combine your numerators together now. You are now combining your numerators together. So simply meaning to say here, I'm going to have this as, all right, since I can see that these denominators are the same. The denominators are the same. So I'm just going to have this as my LCM as it is, because it is the same. Just like here, guys, it was C so everything is now affected, or everything is now over C. So this is what you're going to over the common denominator that we see throughout, which is what? X minus 3 into x plus 2. So this is the same as what we now have here. This is the same as what we are now having here. This is the same as what we are now having here. Take note here, the order does not matter. These two are the same as x minus 3, x plus 2. So what's going to happen now with these numbers in the numerator? Like I said, guys, once these denominators are the same, once these are the same, you just combine the numerators as you combine them as they are. As they are. All right, what am I trying to say? I'm going to take this x plus 7 as it is, x plus 7, the minus 3 into x plus 2 in the numerator as it is. So it's minus 3 into x plus 2 in the numerator as it is here. I've got 1 and plus 1 and x minus as it is, guys. As it is, and considering your brackets, because the brackets, they mean that you're expanding, and after expanding, you can collect your like terms. So this is what I'm trying to say. Once you have this, you can be able to combine your numerator together to give you a single term, same as your normal addition and subtraction that you are used to. So this is another method that you can talk about. All right, so let us consider here, expand our numerators. We're going to have x plus 7, there's nothing to do here, but this bracket is being multiplied by a negative 3 in that case. So it's going to be negative 3 times x, negative 3 times 2. So if we multiply negative 3 times x, that will be negative 3x, all right? Negative 3 to positive 2. So negative 3 to positive 2, that is going to be a negative 6, all right? You do the same thing, plus 1 is going to affect everything in this bracket. So that means you're going to have plus 1 times x, which is going to be plus 1x, which is 1x is same as what? Is same as x. You move on, plus 1 to minus 3, which is going to give you a minus 3. And this whole part is going to be over our denominator as it is, which is x minus 3 into x plus 2. So there, guys, you can be able to collect your like terms. Remember, we talked about the issue of like terms. So that means here, I'm going to consider x. Here, there's a 1. All right. Here, there's a minus 3. And here, there's a 1. So I'm adding 1 minus 3 plus 1, of which you can just do that on your calculator. All right. Just do that on your calculator. If you have a confusion with the directed numbers, guys, remember the calculator is there to assist. So that's 1 on x, which is 1, minus 3. So that's a minus 3 plus 1 like this, which is going to give you a negative 1. So it's negative 1 on x. So it's going to be negative 1x like this. But minus 1x is same as what? Is same as minus x. You move on to the numbers. You do the same thing on the numbers. This is 7, all right? This is minus 6. This is minus 3. So you're going to take these numbers together. You combine them, the numbers only. So that's 7, all right? Minus 6, minus 3, like that. So this is going to give us a negative 2, all right? So thus we are going to obtain a negative 2 in that case. Everything over our denominator, which is x minus 3 into x plus 2. In most cases, most of us will leave our answer here and say we are done. Guys, we are not yet done. Remember, this is simplification that is happening. So in whatever that you're simplifying, try by all means to make sure that it is in the simplest form. Check what you have in the numerator. Is there anything common in the numerator? If there is anything common, make sure that you can factorize. Like here, you can see that in the negative, which is common. So I can factor out a negative as negative 1. So that it will be negative x divided to negative 1, which is going to give you a positive. Negative 2 divided to negative 1, which will give you a positive 2. We have factored out a negative. That means we are going to have the bracket of x minus 3 into the bracket of x plus 2. And remember that as long what you have in the numerator is the same as what you have in the denominator, you can be able to cancel that part. That's, we have got the bracket of x plus 2 and the bracket of x plus 2. So this will give us -1 over x minus 3. So we are going to have -1 over x minus 3 at the end. All right, so that was it. This question had actually a lot of things to consider, but it's not that much. As you can see, it's not that much, guys. It's not that much. All right, this is where we started here. So like I said, we can consider having this so that you just have a common denominator throughout. This is the same as what we have here, the same as what. So once the denominators are the same, if your denominators are the same, once they are the same, you combine whatever that you have in the numerators, all right? You combine everything in the numerators as it is. So by combining this, we are now having this part, expand your brackets. After that, you are supposed to collect your like terms. By combining, do not forget that sometimes you might reach a condition where there are common terms like what we had, where there's a common term where you can factor out and you can be able to cancel out at the end like what happened. So now we have simplified in the simplest form. All right, so that was our question here on question 1.32. It was actually 5 marks. All right, that's why. But actually it's fine. For revision, guys, these questions, they are fine. For revision, it's fine, actually. All right, let us check 1.33. 4 to the exponent of x plus 1 being multiplied to 9 to the exponent of x, and everything is being divided to 6 to the exponent of 2x minus 1. So this is just a mere expansion. You are just expanding these in terms of the simplest numbers that you can have between 4, 9, and 6, in terms of the smallest or the simplest numbers that you can have. Remember, 4 can be written as 2 to the exponent of 2. So it's going to be 2 to the exponent of 2, but that exponent of 2, it has to affect the exponent of x plus 1 that we are already given, which is the same thing. 9 can be written, remember, in the base of 3, which is same as 3 to the exponent of 2. That is 3 times 3 gives us 9, but being affected by the exponent of x. So that will be 2 times x, which is what? Which is 2x. All right, now you have to consider this part. We have got 6. We do not have a number that we can just take direct and like 2 to the exponent of a certain number, it gives us a 6. Like what we're doing on 4 to say 2 to the exponent of 2, it's 4. 3 to the exponent of 2 is 9. 6, we do not have a number like that. So what are we going to do? Are we just going to write it like that? We were supposed to write it like that, but now because we have 6 in expanded form of 2 and 3, that means we are going to expand that in terms of 2 and 3. Remember, 6 is same as 2 times 3. So 2 times 3, it gives us 6. But it is being raised to the exponent of what? To the exponent of 2x minus 1. And remember from our laws that if you have a times b being raised to the exponent of m, every term is going to be raised to the exponent of m. That is, we are going to have a to the exponent of m times b to the exponent of m. So if I have a condition like this, it means I'm going to raise 2 to the exponent of this, 3 to the exponent of this. Every term is going to be raised to the exponent of 2x minus 1. So I'm going to have 2 to the exponent of 2x minus 1 multiplied to 3 also raised to the same exponent, which is 2x minus 1. That is from this law. So that means you can be able to expand whatever that you're given, guys. And here you can be able to simplify. All right, it's only because here we did not simplify. But anyways, let us just simplify it once. We've got an exponent and an exponent. Remember, on that condition, you have to multiply throughout by 2 to expand the bracket. So you're going to have 2 to the exponent of 2 times x, which is 2x, 2 times 1, which is 2. Each and every term you multiply by what? You multiply by 2 times 3 to the exponent of 2x, everything over 2 to the exponent of 2x minus 1 times 3 to the exponent of 2x minus 1. So in this case, I want you to see what is happening here is that you've got the same denominators in this case. I mean, we've got the same basis, like a condition of 2 and 2 in this case, and we are dividing a condition where the bases are the same. So what are we going to do? You are simply going to subtract the exponents in that case. So this will be, we're supposed to have 2 to the exponent of 2x plus 2 like this, minus the exponent that we have on 2 in the denominator, which is 2x minus 1 like that. All right, expand by a negative. To expand the bracket, you're going to have 2x plus 2. Because the negative, it must multiply everything. It must influence. You are subtracting every number here. That's why you open a bracket. So it's -1 times x here, the same as a -1. So -1 times 2x, -2x, -1 times -1, which is going to give us a +1. Negative, that's a positive. So if you collect your like terms, you're going to have 2x minus 2x. That's 2 minus 2, which is a 0 in that case. So you are left with the 2 plus 1, which is 3. So you're going to be left with the 2 to the exponent of 3. In the whole simplification of these two, it is going to give us what? 2 to the exponent of 3 at the end. So that's 2 to the exponent of 3, all right? Multiply the 2. You do the same on these 3. We do the same because we are dividing there the bases that are the same. We are talking about the base of 3. So you're going to subtract our exponents in that case. So that's 3 to the exponent of 2x minus the exponent that we have on 3 here is 2x minus 1. So that's going to be 2x minus 1 like this. So you expand your brackets here by a negative. So you're going to be left with a 2x, -1 times 2x, which is -2x, -1 times a -1, that's negative, which is a positive. So if we collect the like terms, that's 2x minus 2x, which gives us a 0. So you're going to be left with the 3 to the exponent of what? Of 1. So this was going to give us 3 to the exponent of 1. If we simplify the whole of this part that we see here, it was going to give us 3 to the exponent of what? Of a 1. So the question is that, yes, I'm now having 2 to the exponent of 3 being multiplied to 3 to the exponent of 1. But can I simplify this? This one we can simplify. Remember, 2 to the exponent of 3 simply means 2 times 2 times 2. That's 2 times 2, which is 4. Then 4 times 2, which is 8. So you're going to have 4 multiplied to 2, which is going to give us an 8. So that's 8 times 3 to the exponent of 1 is 3. Remember, any number to the exponent of 1, it remains as it is. So that is going to be 3. Then you can multiply 8 times 3, which is going to give us 24 in that case. So this is going to be 24 at the end. So as we can see, guys, this was the whole scenario of our question, the situation that we're supposed to have in this case. So if you work out properly your questions, guys, you are not going to have a challenge. No. You are not going to have a challenge. Please do revise as much as you can your questions. All right. So anyways, let us check the other part. They on question 1.4, they are saying that let us see our question. If x is an even number, all right, we have got x being an even number that we have. All right, x is an even number and x is greater than 1. So even numbers that are greater than, we've got 2, 4, 6, 8. Those are the even numbers. All right. Arrange the following in ascending order. So this one, how can we can just test, guys, to say if we raise to an exponent of an even number, what's going to happen here? So if you know, you can just write your answers direct. But if you are someone like me, guys, just test. You've got a calculator, guys. You are in exam. You have a calculator. Whether it's 2 marks that you have there, it does not matter. Use your calculator, test your values. So how do you test? Because we want to write this in ascending order. Ascending order, that is from the smallest to the largest value. To the largest value, starting from the smallest to the largest, from the smallest to the largest value. That is in ascending order. Descending order, because they can say descending order, is from the largest to the smallest. So the question is, like I said, you test your values because you are given these are integers, and we know that the smallest integer that we can have 2, 4, 6, 8, and so on. The smallest integer that we can have is what? Is 2. So just test your values using your calculator, guys, so that you can quickly see what is happening. All right. So this negative 2 to the exponent of x. Let us try and check on our calculator. You can check if x is equal to 2. Like I said, I'm going to check if x is equal to 2. All right. Because they said x is supposed to be an even number and greater than 1. So I can just take any even number of my choice and compare in terms of numbers that I can see, that I understand. Because this one, most of us, we do not understand this. All right, so let us test and see. I'm going to start with the first one. Remember, I said we're going to test if x is what? If x is 2. So this is negative 2 to the exponent of x. So that's negative 2 to the exponent of x, and our x is what? Our x is 2. So that's negative 2 squared, which gives you a negative 4 in that case. All right, so here we are obtaining a negative 4. All right, we move on to 2 to the exponent of x. If x is 2, that's 2 to the exponent. This one you can just get direct, guys, which is what? Which is a positive 4. You move on to 2 to the exponent of minus x, but remember that your x is what? Is 2. So that's 2 to the exponent of minus x. Our x now, our x, this one is what? Is 2. So in place of this exponent, you're going to put a 2, which will give us 1 over 4, which is a decimal. That's 0.25. So this is 0.25. You move on to 2x to the exponent of 0. But our x is what? Our x is 2. So that's 2 to the exponent of x. Our x being what? Being 2. But that 2 being raised again to the exponent of what? Of 0, like that. So this is going to give us a 2. All right. You move on to 2x to the exponent of 2, where x is what? Where x is 2. We're going to substitute 2. So that's, this time is going to be to the exponent of what? Of 2, like this, which is going to give us a 16. So this is going to give us 16. Now, guys, we know these numbers. We are used to these numbers. We can compare to say which number is bigger, 2 or 16. We know this. So once you do this on your calculator, now you can properly compare to say, all right, of these numbers, which one is the smallest? Because we said in ascending order means you are starting from the smallest to the what? To the largest value, from the smallest to the largest value. So what is the smallest value compared to these decimals and whole numbers? Obviously, it's the negative. Before you talk about a decimal, the smaller value must carry a negative. If you're comparing -3 and 10, all right, -3, the one that carries a negative is the smallest. If I compare -10, maybe it's -10 and 3 like this. -10, no matter how big it is in terms of this number 10, it is small as compared to 3, because 3 is what? It's on the positive. -10 is on the negative, so it's very, very small. So meaning to say, of these numbers, we only have one part that is giving us a negative here of 2 of this one. So that means this is the smallest one, -4. But we took this -4 from where? From -2 to the exponent of what? X. So we're now writing in the order of what? Ascending. All right. Compared after negative, do we still have any negative? We do not have. The rest are positive. So in terms of positive, definitely 0.25 is small because the decimal, these are all numbers. So 0.25 is very small. Where are we obtaining 0.25? We are obtaining it from where? From 2 to the exponent of -x. You move on. After 0.25, the smaller value compared, it's 2. All right. 2 is from where? 2 is from 2 x to the exponent of 0. You move on, followed by what? By 4, smaller. From where? From 2 to the exponent of x. And the last value being 16. From where? From 2 to x to the exponent of 2, like that. So this is what they are saying in ascending order, in order of size. But you can't see this order of size if these numbers are written this way. It's best for you to write them in way that you understand. Just substitute any value of x of your choice, then you compare. But that x must be an even number, must be an even number. It can be 2, you can use 4, you can use 6, you can use 8, any number that you want, as long as it's an even number. And that even number greater than 1. So that is the order that you're going to have in what? In ascending order at the end. All right. So that was our question 1.4. Let us just hope we understand. So that was 18 marks at the end on this question number 1. So question number 1, as you can see, it is one that had a lot of things to consider. You see that the rest of these questions, they are just direct. All right, question 2.1 from question 2, actually here 2.1. So for x, what is it that I'm supposed to do in this case? 2.11, as you can see, there's a square root. So you're given the square root of ax is equal to b, and you want to solve for x. So you can simply remove the square root, remember, by squaring both sides, you remove the square root. So the square root and square, you remain with ax, which is equal to this side is b to the exponent of 2. This one is same, there's a 1, so 1 times 2, that is a 2. So how can I make x the subject? Here you are multiplying, so to solve for x, you divide by a, so that this will cancel, you get a 1. 1 times x, which is x is equal to b squared over a. So in this case, I have x, which is equal to b squared over a. I have solved for x in that case. All right. Let us consider the other question that we're given, which is on 3.12. Solve for x, and again, we are given 3 to the exponent of x plus 3 to the exponent of minus 1, which is equal to 36. On a normal consideration of this type of a question, what you're supposed to do is to factor out the 3 to the exponent of x that we are seeing being common. But how can we do that? We can simply separate this as 3 to the exponent of x plus we have 3 to the exponent of x minus 1. So there are two ways that you're simply asking yourself to say, how was it written before? How was it written before? What made you to subtract this? You were dividing 3 to the exponent of x. It was divided to 3 to the exponent of 1. Remember, that was the condition that made us to subtract our exponents like this. So this is equal to 36. So as you can see, I have properly separated this so that I can see properly my 3 to the exponent of x that I can factor out because it's now common. So if I factor out 3 to the exponent of x, here I'm going to divide this and this is the same, I get a 1. This and this are the same, so I'm going to get a 1 on 3 to the exponent of x. That's where you get a 1, just like here, you got a 1. So it's going to be 1 over, guys, 3 to the exponent of 1. It's a what? It's a 3. There's no need for us to keep on rewriting this and that and that. All right. So the question is, we are done once we're at this stage, guys. We are done because what you simply need is to remove the bracket that we have this one. Because what we want, guys, is x. And this is the part that is carrying x, which is the exponent. So I'm going to be left with 3 to the exponent of x is equal to, on this side, I'm going to simply divide by this bracket to remove the bracket on that side. All right, let us go to our calculator, guys. Whether I know the value of this or I do not know this value, it does not matter. Our calculator, it knows everything. All right, so let us simplify here. So it's gonna be 36, this on the left side, on the right side, divided to the bracket. So you're gonna open a bracket, 1 plus 1 over 3 like this. You close your bracket. So this is going to give you a 27. So this is equal to 27. So once you're at this stage, guys, remember that you can make the bases to be the same. In the base of 3, it follows that 7 can be written in the base of 3, which is 3 to the exponent of 3. So once you have this, you can equate your powers because these, the exponent, because these bases are the same, you're gonna equate your exponents at the end, all right? So because we have got same values 3 and 3 here, so you equate your exponents at the end. So that's therefore our x is going to be equal to, our x is going to be equal to 3 because this part here, it's like you will cancel it because it's not there. You just equate your exponents if the bases are the same. So that is how you could have calculated the value of x, and as you can see, it's direct. Then on 2.12, given the inequality that we are given here, so for x, this inequality, so here, guys, as you can see, it's again a direct question that you just needed to be very careful on your simplification because we have got one inequality there. So if you have got one inequality, do not worry, just take your values to the one side, So you can just take this to the other side here so that it becomes a negative. It was a positive here. So it's going to be x over 3 minus x over 2, which is greater than 1. So the changing of number to another side or terms to another side on an inequality, it does not affect your inequality sign. The inequality sign is affected when you divide by a negative or to multiply by a negative. That's where it reverses. So here I'm going to simply subtract. This is 1 over 3 minus 1 over 2 because I've got x and x here, which is common. So on my calculator, I'm just going to subtract 1 over 3 minus 1 over 2. All right, so that's 1 over 3 like this, minus 1 over 2 like this. So this is going to give us negative 1 over 6x, which is greater than 1. So remember, we want to get a value of x, and there there's a 1, and here there's minus 1 over 6. So how can I remove this negative 1 over 6? I simply have to divide it on this side. But remember, you are dividing by a negative this side. So what happens if you divide by a negative here? This inequality sign, it reverses, it changes the way it is facing. It is going to face this side like this. So it means now x will be less than the answer that we are going to get if we divide 1 to this value. So it's simply 1 divided to the answer that we had, which was minus 1 over 6. Remember, we are going to obtain a negative 6. So we are saying x is less than minus 6. That was supposed to be your solution at the end. X is what? Is less than negative 6. Then they're saying if x being an integer, write down the first 2-digit number that satisfies the first 2-digit number. A 2-digit number is a number that has got 2 digits, like 20, 31, 42. They are 2 digits. So they are saying write the first 2-digit number. So it's a direct question here, but guys, because all right, this is 2. All right, this was 2.21. Then here is now 2.22. Remember, they said x is an integer. That's the most important part. X being an integer. So what is it that you are going to consider if x being an integer? Talk about positive or negative numbers. And from this inequality that we solved, we got that x is less than minus 6. So if x is less than minus 6, we know that on our presentation, in actual sense, we're supposed to have our number line in this case, whereby this is a 0, this is negative 6. We consider values that are on this side, which are less than negative 6. From negative 7, was negative 6 is not involved. So we're talking about from negative 7, negative 8, negative 9, negative 11, negative 11, negative 12, and so on and so on. These are the numbers. So the question is saying, on all these numbers that you're talking about, which one is the first? The first, that is the most important part, 2-digit number. So the first 2-digit number here will be at negative 10. This is our first 2-digit number, this one, which is a negative 10. So that's our first 2-digit, the number that has got 2 digits. 9, 1 digit, here, 9 digit, 1 digit, 1 digit. So as you can see, yes, after negative 10, negative 11, negative 12, all of these ones, they're now negative, they're now 2 digit and so on. But the first 2-digit number there is going to be a negative 10 as we go in that direction. All right, 2.3, solve for x and y simultaneously, and that was 4 marks for that simultaneous equation to be solved. All right, so you're given 2x plus y, 2x plus y is equal to 4, and 3x minus y is equal to 11. Let us see if we can just solve them aside here. So that is question 2.3. So you're given 2x plus y being equal to 4, and another equation, it was 3x minus y, which is equal to 11. So there are 2 equations. You can use elimination, you can use substitution, you can use whatever form of an equation that you want. So in this case, I'm just going to work with a substitution. From equation 1, I can just make the subject from equation 1. This is our equation 2. Or you can write 1, 2. It's one and the same thing. Or you can even write A and B. Guys, you write the way that you want, all right? So from my equation 1, I'm going to make y the subject. It's easy, or I can even make y the subject from equation 2. You choose which one that you want. All right, so as for me, I'm going to work from equation 1. All right, so from equation 1, I'm going to make y the subject. All right, make y the subject. That is, I'm going to transpose all other terms and remain y as the subject. So I'm going to transpose this to the other side. It becomes a negative. So that means y is going to be equal to 4 minus 2x. This I made it from equation 1. If you wanted to make it from equation 2, it's up to you guys. You can do it that way. So it's not like you have a limited thing. No, you can do it that way. You can work it from your equation 2, which is actually fine. All right. But in equation 1, it means now I have another equation that I formulated from equation 1. I can name this equation 3. So this is now my equation 3. So what you do is that you substitute in the other equation. You do not substitute back here where you have made the subject. No, you substitute to the other equation. That's where you substitute. So you are going to substitute this equation. I'm just going to write in short, equation 3 into 2. All right, into equation 2, not 1, not this one. If you made y the subject from equation 2, you are going to substitute in equation 1. Don't substitute where you have made the subject. All right, so that means in place of y, I'm going to substitute 4 minus 2x in place of y. So this is going to be 3x minus, in place of y, I'm going to substitute, this is y here, which is 4 minus 2x. So I'm going to substitute minus 4 minus 2x like this, which is equal to 11. So guys, that's it. I now have an equation which is only in terms of x. So if it is only in terms of x, I can be able to solve for x by expanding the brackets. This is same as -1. So it's -1 times a +4, which is going to give us a -4, -1 to -2, negative. Remember, that's a positive. So that will be positive 2x, which is equal to 11. Yes, I can just transpose. I can just combine my terms on the left-hand side because these are common terms, 3 and 2. If I add 3 plus 2, I'm going to obtain 5x minus 4, which is equal to 11. So remember, this is an equation, guys, whereby we are supposed to solve for x. So I can transpose the -4 to this side so that it can be a positive on that side, all right? So that means 5x is going to be 11 plus 4, which is 15. So to find x, simply divide by 5. Since here you are multiplying, your x will be equal to 3, all right? 15 divided by 3, you can just even use your calculator direct, guys. You're going to obtain that x is going to give you a 3 in that case. All right, so this is the value of x. So where am I going to find the value of y? To find the value of y by substitution, you can go back and substitute in equation 1. This time you can even go back and do that. You can go back to equation 2. You can even go back to equation 3. So as you can see, of all these equations, the best equation to use is equation 3. Why equation 3? Because already y is the subject and we want to find the value of y, and already there y is the subject because we have written that y is equal to 4 minus 2x, and we have the value of x. Yes, we can substitute in this equation 3. It's best to use because we have the value of x and already y is the subject. So we're just going to substitute direct minus 2 times x, which is 3. So y is going to be 4 minus 2 times a 3, that's a -6, and y is going to be 4 minus 6, which is -2, of which you can just use a calculator like I mentioned before. So this was going to be the value of y, and this was going to be the value of x, which satisfy our our simultaneous equation that we were given there on top, right? So that's it. As you can see, it's actually worthy. The marks is direct. You can even use elimination. Guys, solving simultaneous equations, it's in your hands. You do the way that you feel like it's best for you. So that was question number 2. Yeah, 12 marks for that. So you can see, so question number 1 was the one that had a lot of things. All right, anyways, let us see. Question number 3, we are now given, study the pattern. Study. It's not just written. They want you to figure out by yourself what is happening. That's why they write there, study the patterns. All right, below, and answer the questions that follow. this is pattern 1. Let us study what is happening. Pattern 1, there are sticks here. These are the patterns are in the first 3 terms of a sequence, all right, for which the value of the term is given by the number of sticks in the pattern. So they are saying it's in terms of 3 terms, but the value of the term, this is the most important part, the value of the term is given by the number of sticks in the pattern. So what does it mean? This is pattern 1. So it means T1, which is the term, the value of the term, because it's pattern 1, T1 is equal to the number of sticks that we have. How many sticks? 1, 2, 3. So there are 3 sticks here. 1, 2, 3. So meaning to say T1 is equal to 3. That is your first term. You move on to the other part, which is this part here. Put how many sticks on T2? 1, 2, 3, 4, 5 sticks. So that's our T2 is equal to 5. That is what they mean, is equal to 5. You move on. The third one, that is 1, 2, 3, 4, 5, 6, 7 sticks. So T3, which is for pattern 3, our T3 is equal to 7. This is what they are simply saying. So the question is that on this part, write down the number of sticks in each of the first 5 terms, right? So they're saying write down the number of sticks in each of the first 5 terms. These were the first 3 terms. So the first 5 terms, it's a continuation T1, T2. So you've got 3, 5, 7. This is our numbers there, term 1, term 2, and so on. All right, so that's 3.1. So remember, we had 3, 5, 7. Those are the numbers that we had corresponding to term 1, term 2, term 3, 3, 5, 7. So this is our first term, T1, T2, T3, and so on. So T4, which one is going to be our T4 and our T5? So if you consider this, if you check here, there's a common difference between these 2 numbers. There's a difference of 2 there. If you subtract 5 minus 3, that there's a difference of 2. 7 minus 5, there's a difference of 2. So it means to get the number in the next term, we are simply going to add the difference that we are seeing of what? The difference of 2. So this next number is going to be 7 plus 2, just like 3 plus 2, I get a 5. 5 plus 2, I get a 7. So it means if I add a 2 in this case here, 7 plus 2, I'm going to get a 9. I do the same thing to give the 50th term. I'm going to add a 2 again. 2 added to 9. 9 plus 2, I get 11. So it means this is what I was going to have at the end, all right? In terms of the 50 terms, at the end, I'm going to have 11 sticks representing this part. All right, so that was our first question, 3.1. Then on 3.2, they're saying write down the general term Tn of the sequence. Remember this sequence that you're talking about here, where there's a common difference, we said it's an arithmetic that you're talking about, a linear part, a linear pattern that you're talking about, whereby we know that it can be written in short. If you understand this, is going to be best for you, where I say Tn is equal to Bn plus C. Okay, what does it mean? B, this B here, you need to know about B mostly. This is going to be most important part for you to understand. This B here is the difference. That is the common difference that you have there, the common difference. So let us just write the common difference, which is our common difference is what? Is 2. So in actual sense, it's our gradient. The gradient, like the difference, the change in values, they are changing by 2, by 2, by 2. So that is what you're going to have. So it means Tn is equal to our difference, which is 2n plus C. In that case, you're going to find this C by substituting any of the corresponding part. Remember, we are saying T1 is equal to 3. This is the first term, like n is 1. When n is 1, T gives us 3. When n is 2, T gives us, that is what it means. 1, when n is 1, we are saying when n is 1, T1 is 3. T2 is 5, meaning to say when n here is a 2, you must get a 5. If n is 3, you must, so you can use that as an advantage now to get the value of C, because you simply know that these numbers here, they represent n. So for T1, for this T1 that I'm having, it means when n is 1, I'm going to have T1, which is 3. Here it's going to be a 3. So I'm going to form an equation. 3 is equal to 2 into 1. Remember, our n is 1 plus c. So that means 3 is equal to 2 plus c. Can transpose 2 times 1, which is 3. So you're going to transpose 2 to the other side. It's going to 3 minus 2, which is equal to 1. So 1 is equal to c. So if c is equal to 1, therefore, we're going to write our Tn as 2n plus c, which is our c is 1. So it's going to be plus 1. So that was going to be the expression for the Tn. All right, that's it, guys. As you can see, 2 marks is actually important for this to achieve everything on this type of equation. 3.3, solve for T131. All right, solve for T131. T131, what does it mean? All right, this is our Tn, guys. All right, this is what it means here. All right, this is what it means. 3.2. T131, it means our n is equal to 131 here. Remember, it's Tn, n. So there we are given n, which is 131. So if n is 131, what is the value for T131, guys? It's just substitution that you're simply making. So T131 is going to be, in place of n, you substitute 131. So it's going to be 2 times 131 plus 1. So you're going to multiply direct on your calculator, or you can multiply these 2 by your calculator. Then you add, which is going to be 262 plus 1, which is 263. So that is our T131. When n is equal to 131, what is the value of what? Of T131. So that was our question here. Question number 3, as you can see, everything here, it was just 6 marks for the number patterns, which is considering our sequence and so forth. So guys, just revise as much as you can. All right, so let us check the other part. We still have another part here, which is question number 4. The graphs of f of x. We're given the graph of f of x, which is minus x squared plus 4. All right, minus x squared. Let me just try to do this and this. All right, so this is our f, this one. All right, so this is our f of x. All right, minus x squared plus 4. Let me just write, so I'm gonna remember this. All right, minus 2x squared or minus x squared. Minus x squared plus 4. Are they saying 2x squared? All right, minus x squared. All right, then this one is for mx plus c. The g is for mx plus 2. All right, so they are sketched. A and E are the x intercepts of f. All right, this A and E, which is truly, they are the x intercepts, yes. B and D, all right, are the y-intercepts of f and g respectively. All right, B and D, the y-intercepts are f and g, they intersect at A and C. So they intersect here and also intersect here, which is true. All right, so let us check our questions. So the first part of our question, it was write down the coordinates of B and the coordinates of B and D. All right, that is our first part of the question, 4.1. Determine the coordinates of the points B and D. So where do we have B? That is the question. B is here. Remember, B is the value that we have on the y-intercept, in that case where x is equal to 0. So this is the y-intercept of the graph of f, all right, from the graph of f of x, which is negative x squared. All right, f of x, remember, it's negative x squared plus 4. So it is the y-intercept where x is equal to 0. So you're going to substitute when x is equal to 0 here, it means y is going to be equal to 4. So that means as a point here, the point B here is at 4. All right, the point B is at 4. So that's 0, 4. Remember, the x value there is as 0. So the point B is going to be given as 0, 4. All right, what about the point D? Where do we have the point D? The point D is the y-intercept of what? Of the straight line of y is equal to mx plus 2. So this is mx plus 2. The idea is not going to change. In the y-axis, x is equal to 0. So if x is equal to 0, you're going to have any number times 0. Remember, it's what? It's a 0. So that's 0 plus 2, which is a 2. So that is our y-intercept is at 2. So the point D, therefore, is going to be 0, 2. or you can just take the value that we see here. Remember, our equation is written in the form of y is equal to mx plus c, where c is the y-intercept, and the y-intercept there is given as 2. So that means here there is a 2 at point what? At point D. All right, so that was it there. Then determine the range of f. So the range of f, we can take it from what? From the point at B. Remember, this is our f. So our graph can be taken from this point going down as much as we can down there. It has unlimited points in the negative, but to the maximum, it is limited at what? At 4. So meaning to say y is less than or equal to this value of -4. It cannot exceed this value. So y is less than or equal to +4, which is our maximum value in that case. But we are saying if y is less than this, it is not limited from this 4 as it goes down. As you can see, down it's open. So you can write it from negative infinity. So you can have this as, or y is an element from negative infinity up to +4. So it can be taken from negative infinity up to +4. All right. Determine the length of AE. So in order for you to have the length of AE, you must have the point A and the point E. Where do we have the point A and the point E? Remember, these are the x-intercepts of the graph of f. So we're going back to the graph of f of x, just like what we did on the y-intercept. You calculate the x-intercept this time, whereby for the x-intercept, we know that y is equal to 0. So this is your f of x, which is equal to -x² plus 4. And we are saying for the x intercepts, if whenever you're talking about the x-intercept at that condition, y is equal to 0. That's f of x is equal to 0, -x² plus 4. So in order for us to find x², you can transpose this so that it becomes a negative on that side. So it's going to be +x² is equal to 4. So to find the value of x, whenever you're given a square, you introduce the square root on both sides. So that x is going to be the square root of 4, which is plus or minus 2. So these are the x values that we have at plus or minus 2. So by comparison, by comparing these values plus or minus 2, we can see that the -2 is on this side from the 0 going to the left. These are negative. So at A, we've got -2. At E, we've got a +2. So if we've got a -2 here and a +2, the distance is going to be the difference between these points, because they're on a horizontal line. So you simply subtract to say, from this point to this point, there are 2 units here. If you count, there are 2 from here to here, there are 2 units. So meaning to say I've got 2 units. From 0 to 2, I also have 2 units. So I add 2 plus 2, which is what? Which is 4 units. Or I can use it as a difference, the maximum minus the minimum value. I explained about that. So meaning to say at the end, AC, this is question 4.3. So at the end here, we're going to have the distance of AC, which is the maximum value minus the minimum value. So it's going to be maximum minus the minimum value, which is the maximum value at this value is +2, minus the minimum value, which is -2. So that's negative, which is a positive. So 2 plus 2, which is a 4. So that was going to be the distance of AC, which is 4 in this case, all right? Or you can just write 4 units. All right. That is for AE. Then the other part, which is the G, the 4.3 was to calculate the value of M, which is 2 marks. The value of M, where do we have M? M is actually on this part, which is the M represents the gradient. You can actually calculate M by finding the gradient. There are actually 2 ways that you can do that, because if you write your equation in this form, all right, let me explain this one. This one, guys, we've got a lot of things. All right, this is 2 marks. All right, 2 marks for that. No problem, 2 marks, guys. I wanted to check the question, not the marks. I want to check the question. Like it's question what? 4.4. All right, this is question 4.4. They want us to calculate the value of M. And I'm saying there are 2 possible options that you can make. What are the options? Let us start with this one. All right. 4.4. All right, that's 4.4 if I'm not mistaken. All right. So like I said, M represents the gradient. If I write my equation in the form of y is equal to mx plus c, this is the format of a straight line. this m here, it represents the gradient. So if m represents the gradient, it represents the change in y over the change in x. So if it is like that, I'm going to simply find the gradient of the line AC because I have the point D and I also have the point A. Remember that I have got these points, the point D and the point A, they lie on the line AC. So I can use this to determine the gradient because I understand that the gradient is the change in y over the change in x, which simply means y2 minus y1 over x2 minus x1. So I can use that as a gradient because, guys, remember we have got the analytical part, but this one is going to affect us because of the analytical part. Most of us by that time, we have not done it, but we have yet done it by June, guys. All right. So you're gonna use that. I'm gonna explain another method which most of us can also relate to. So that means here at point D, which is this line, it's a point that you're gonna consider, which is 0, 2 in that case. All right. And here it's negative 2, 1. So meaning to say I've got a point here. The x value is negative 2. The y value is a 0. At point D, the point there is 2, 0. All right. X, it's the value is 0, 2, 0, 2, all right, 0, 2 there, because the x is at 0 and the y value is the one at 2, all right. So you're gonna determine the gradient there, that is the y2, depending with what you want. You're gonna use this or whatever value. So I'm gonna use 2 minus 0, the y to the y, so that's 2 minus 0. So 2 minus 0 over the x value, 0 minus minus 2. So it's going to be 0 minus minus 2 like that. So m is going to give us a positive 1 if you simplify this direct on your calculator. So like I said, I'm going to explain another way, guys. So you're going to have 2 minus 0 on top over 0 minus minus 1 like that. Or it's a 2, not a minus 1, minus 2 like this, which is going to be a positive 1. But with this method, most of us, or we're using the calculator. I did not show the calculator. All right, like this guy's gonna get a positive 1. Sorry for that. All right, let me talk about this method. But remember, m is a letter that is just on an equation that you're given. So you can also take advantage of the understanding of your equation to say, if you are given that y is equal to mx plus 2, already there is a value that you are given there. Already there is a value that you are given there, which is 2. So meaning to say you can think along the line, as long there's a point which lies on this line, you can use that point to find the value of m. Like for an example, let's say I want to use the point D because I calculated the point D as the y-intercept of this, or maybe I want to use the point A because I calculated the point A also. So let's say I want to use the point D. The point D is at a point where y is 2, meaning to say if the y-intercept, so x is equal to 0, y is equal to 2. So this point, I have the value of x and I have the value of y there. So I can substitute what I have. In place of y, I'm going to substitute the value of y, which is 2. So 2 is equal to mx. Mx, our x there is a 0. So remember what I said, guys, any number times a 0 there is going to give us a 0 in this case. All right. So our x is a 0. So meaning say there's nothing that you're going to get because our x is a 0 there. So this one is not going to give us anything because it's going to be 2 is equal to 2. So this one was limiting us because of this 0 here. So we are not going to win if we use the point D. Sorry for that. So let us move on. It's not to say it's wrong if that point was on a line. If the point is on a line, it must give us that. But because of the x, which is 0 there, you're not going to get a value. So you move on to another point if it is a scenario like that. Another point which lies on this line is the point A. So the point A, x there is minus 2. So this one can work because x is negative 2. So I'm going to substitute x being negative 2, y being a 0. So in place of y, I'm going to substitute a 0 there. So 0 is equal to, in place of x, I'm going to substitute negative 2. So it's going to be negative 2m. Remember, m times negative 2, it's negative 2m. All right, plus 2. Remember, I want to solve for m, so I can transpose this to the other side. It becomes a positive. So that means 2m is equal to positive 2. To find m, divide by 2, divide by 2. So therefore, our m is going to be a 1. 2 divided by 2, guys, remember that's a 1. So that's how we could have calculated again our M. As we can see, we're obtaining the same answer, just like the previous question. All right, then on 4.5, they are now saying here, all right, let's see. Determine the coordinates of A and C, the points of intersection of F and G. All right, the point of intersection, because now we have the value of M here, which is 1. So you can form equations. Remember, the point of intersection, we solve the given equations simultaneously. Now that we have the value of M, it means here on Gx, it means, remember, our Gx was Mx plus 2. So it means now Gx is going to be equal to 1x plus c, which is x plus what? Which is x plus 2. So we have the equations, guys, and we know that at the point of intersection, these two equations are the same. So you solve them simultaneously at the point of intersection. So remember that at the point of intersection, solve the given equations simultaneously. Solve the given equations simultaneously. The given equations simultaneously. So that is what you're going to do in that case. You're going to solve your given equations simultaneously. So which equations are we talking about? Which equations? All right, we've got the one for f of x. Remember, I given f of x is equal to minus x squared plus 4. So we've got the one for f of x. All right, so you're going to consider that one for f of x, which is negative. We've got g of x, which is same as y is equal. Let's just write y is equal so that we understand y is equal to minus x squared plus 4. This is for our gx. Then for f of x, it follows that y is equal to x plus 2. Remember, we calculated m, so there we're going to write as x plus 2, as I mentioned before. So it's an advantage that when you are dealing with equations, guys, I want you to take note this, and we can learn it as quick as we can. It's an advantage that you can just substitute here because y is the same. So it's either I'm going, guys, it's no way to say I'm going to substitute this here or I'm going to substitute here. Everywhere. So whenever you've got a y like this and another y like this being the same, it's not like I'm going to substitute this one this side, or you just equate the rest of the part of your equation. This one, you equate it to this side so that they are the same. So you're simply going to equate these two. What am I trying to say? I'm trying to say this minus x squared plus 4 must be equal also to x plus 2. So that's an equation. All right, let us collect our terms and see what we're going to have to this side. We're going to have minus x squared plus 4. Transpose x to this side, it becomes a negative. So that's minus x. 2 to this side, it was a positive. It becomes a negative 2. This is equal to 0. So as you can see, guys, we can be able to solve for x from this equation. If we collect our like terms, this will be minus x squared. We've got minus x in this case. Then we move on to the numbers. On the numbers here, we've got 4 minus 2 in that case. All right, so 4 minus 2, that's a plus 2, which is equal to 0. So you can solve this equation. Remember, this is now a normal equation that I'm supposed to solve, a quadratic equation that I can solve by what? By factorization. But in order for us to solve this equation, guys, it's best that we make x squared a positive, and there's a negative. So how can I do that? I can simply divide by negative, by negative, by negative throughout the equation, so that negative, negative, it gives us a positive. Negative, negative, it gives us a positive. Positive to negative, it gives us a negative. 0 divided by any number, guys, that's a 0, all right? Does not care it's positive or it's negative. 0 is just a 0, all right? So there I can factorize because I have the coefficient of x squared, which is 1. So I can just have 2 brackets, equate them to 0. So this is x and this is x. So what am I going to do? I'm going to consider, remember the factors of the constant that you add up to get 1. So the number here is a positive 1. 1x, it means there is a positive 1 on that case. So what are the factors of negative 2? 2 numbers that you multiply to get a negative 2. It's either one of these numbers must be a negative so that you get a negative 2 when you are multiplying. So it's either one of the numbers must be a negative. So it's either we've got negative 2 and 1, or we have 2 and negative 1. one of the numbers must be negative. But the question is that which part are we going to add and get a positive one if we add? So if we add these two, we get a negative one. Minus 2 plus 1, that's a negative 1. If we add these two, 2 plus minus 1, that's a positive 1. So this is the one that's going to satisfy our value, our condition. These are the values satisfying 2 and what? 2 and minus 1. So we're going to have 2 here plus 2 here minus 1 is equal to 0. So there we can solve for the point of intersection. That is, we're going to solve. Remember, one of the brackets must be equal to 0. Another part must be equal to 0. So you're going to take this, equate it to 0. So that's x plus 2 must be equal to 0. Or take this equal to 0. That's x minus 1 must be equal to 0. So if I transpose 2 to the other side, it becomes a negative 2. That's a negative 2 there. All right. Then if I take negative 1 to the other side, it becomes a positive 1. So these are the x values that we are going to have. X being a negative 3 and x being a positive 1. But the question is, these are supposed to be points determine the coordinates. So you need the coordinates like the value of x and the value of y. Right, let me check something here that we could have. All right, actually, we're just supposed to solve because the 2 marks are just, all right. Here we see that A already, we solved it previously. A we already have. So to find the C, here it means we have to take one of the values that is remaining here. Remember, of these values that we solved here, this is what we solved, guys, on 4.5, right? I'm considering question 4.5 here. This is the one that we solved here at 4.5. So we obtained the two values, one being minus 2 and other one being positive 1. So the minus 2 is this one at what? At the point A. So meaning to say A is the one at negative 2, 0. All right. What about C? This one, C, because we now need C. So C will be the one that is at what? At positive 1. So if X is positive 1, what is the value of Y? We are going to just substitute in any of these equations. I can just substitute on this one. If X is 1, that's 1 plus 2, which is going to give us a 3. So that's the point C is going to be 1, 3. So these were the points that were given, the coordinates of the point of intersection. And the last part of our question was, in this case, if it is given that, all right, this one was a type of a question that you just have to understand. They're saying, kx, if kx function, it's a function, this one that you're considering of kx, is equal to minus gx. All right, to just write like this, that kx is equal to g of minus x. It's a transformation that we know this one. It's a transformation that we understand, which is a reflection. Remember, it's a reflection that happens in the y-axis. This one is a reflection in the y-axis. We know this, right? If it is minus, like if it is minus gx, it's a reflection in the x-axis when it is written like that. So the question is, if we reflect this in the x-axis, what is going to happen if we reflect gx? This is our gx, all right? So like I said, it's a question of understanding. If we reflect gx, this is our gx here. Let us put it this way. Let us put it down like this. This is our gx, all right? This one, our gx. So if we are to reflect, this one is not, let me just remove so that we can see. I'm just gonna use some of the values we know them. So if I reflect this gx in the y-axis in this line, if I reflect it in this line like this, what's going to happen? That is the question. If I reflect this line along the y-axis, what's going to happen is that the points that we had on this side will be seen on the other side. So we're just going to have a condition maybe of something like this. All right, something like this going in this way, of which it is the same scenario that we have here to say that this value was point of intersection. Now I do not know, it was positive 2, it was negative 2 or positive, something like that. Negative, positive, positive 1. This one, it was a positive. This was the one that was at 2. This was the one that was at minus 2. So it means your graph is going to be like this. So remembering that, remember the point at this one is not important. What is important are these ones. So also this one, it was covering at what? At +1. On the other side, we are going to have this at what? At -1. This is a reflection in the what? In the y-axis. So we have reflected our graph of what? Our graph of gx. That is our kx. So this is now our kx, this line. The line that we are seeing, this one, is now representing kx. It's a function of k that we are seeing. Okay, guys, let me just remove this. It's just disturbing us here. All right. So this is the graph of kx that we now have there. So the question is that they are saying here, for which values are we going to have? Because the question is not about this statement. No, the statement, yes, it's fine, but they are saying, for which values are we going to have f of x greater or equal to kx? So we need conditions where f of x, all right, so we are going to need conditions where f of x is greater or equal to kx. So like I said, guys, kx is the one that we now have this one, which was a reflection. Remember that one, it represents a reflection. If you multiply x, f of, if you multiply x direct like this, all right, like f of minus x like this, it's a reflection in the y. If you multiply it like this, it's a reflection in the x-axis. All right, that's the difference. This one is for the y-axis. So meaning to say, we now have a new graph. This one we are no longer using. It's no longer there. It is the one that helped us to have this one. So we just write it, draw a sketch. So the question is, where are we having our f of x greater than or equal to kx? So we are now comparing on kx. It means, remember I told you, when you are comparing on a graph, a greater than like this, it means we need conditions where f of x is on top. It must be above the graph of kx. Where is it above? All right, this is our f of x, this one. This is our f of x, as we can see, right? It started here. It is below kx. Kx is the one that is on top. Here, we move up to this point, which I said it corresponds as a reflection. It was 1 here. On this side, it is going to be -1. So up to the point where x is -1 here, I want you to see what was happening, guys. The graph of f, this one, the function of f was below the graph of k, meaning to say it was less than, it was in the negative, it was below. But the moment we reach -1 here, they are now at the same point. At -1, they are now both equal because they are at the point of intersection. But the moment we move from this one, I want you to see what is happening. This is your f of x. Your f of x is the one that is now on top. As we move this side, this one is below your kx. It is below up to 0.2 here, as we can see from -1 up to 0.2. Our f of x is on top. We see this f of x here. This is our f of x. It's above kx. So it means f of x is greater than kx on that case, from -1 to 2. So the first condition is going to be from -1 up to 2. All right, let's consider from 2. From the point 2, what is happening? It's now kx, which is the line which is on top now. As you can see, kx is the one that is above. F of x is this one below. F of x is now below. So this one does not satisfy. This condition does not satisfy what we have here. And also this one does not satisfy. It is only this part here which satisfies, where our f of x, we see it above kx. It only happens between x values of -1 to what? To 2. Or you can simply write it in that way to say x must be greater than or equal to, because it's also equal at that point, -1, but less than or equal to the value of x here, which is a +2. So that is at the point of intersection of what we have. So as you can see, guys, it's a reflection of what happened in our previous graph. So it was an interesting question, this one, a very, very interesting question, because it's not direct to the question, all right? It's just a reflection that happened. But take note, we are done, guys. As you can see, we have answered the whole of the paper, which is everything 50 marks. Okay, guys, please subscribe, guys. If you are new to this channel, just subscribe. All right, we are trying by all means to make this reach you guys your point of need. Just subscribe. By subscribing, you're helping us a lot to reach other audiences outside there. Even you like this video, it helps a lot to reach other people outside there. If you want someone to benefit from this part that we are doing, please do subscribe. It helps a lot to reach others, like I said before. Please, guys, please do subscribe. I beg you guys to do subscribe. All right, I wanted to explain this way. If the question was not like what we had to say, they gave us a statement, this and that. Let's say the question was just direct like this. For which values of x is f of x greater than gx? They can have it like that, greater than or equal to gx. If it was like this, guys, you're going to take it direct from your graph. As we all know, we are just going to compare, but this part does not change to say f of x is greater than or equal to. It means f of x is still on top. So if we compare from here, this is our f of x, remember? So f of x along here, it's below, up to this point at -2. The moment we reach -2, if we check, our f of x is the one that is above now. This one is the one that is above up to this point at C, at the point of intersection, at which corresponds with x being 1. So from -2 up to +1, we can see that our f of x is on top, it's above. The moment we reach +1 here, we can see that it is now g which is on top. F of x is now down. So the conditions that we're going to satisfy this question, if it was like this, I'm just saying, guys, this is another question that I'm just giving you to say it can be like that. So meaning to say your x values are going to be taken from -1 to 2, or you can write x is greater than or equal to -2, less or equal to 1. So that is how you can answer these questions. We just hope we are going to have more question papers as we move on revising towards our exams, as we know that exams are just around the corner. So we shall just try by all means to work as much question papers as we can. As we requested, guys, that you must work with full papers. These are the full papers that we have. Can we try to add, guys, please, can we try to add as much as you can. So we just hope for the best to come. Let us keep on working as much as we can. That is what we had, guys, till we meet again.